we come to the third one, basics of the wireless sensor network. One, we already designed the node with all the components we pasted in that. Then we also think about the data aggregation, what algorithm we will use, what techniques we will use for data aggregation, that we also work out. Now we come to the third one, that routing. If I have the information, I aggregate this information, how I can transmit this information to the next node or next to next node. So after sensing the data and aggregate the data need to transmit to the base station for further processing. Routing, whatever the algorithms are there, routing techniques are there, determine the most effective and reliable path for the data travel from source to destination. Here there are two keywords. One is the efficient, another one is the reliable. Every time the reliability is not implies the efficiency and vice versa. Say for example, efficient path is in terms of the fault tolerant, like this one. Efficient in terms of the energy. So this path is very efficient in terms of the energy, they consume very less energy. But some nodes are faulty nodes, maybe possible they goes down after some time. That means that is not a reliable path. So it up to you that what is your requirement. Your routing algorithm requirement most efficient, you are not worried about whether the data is transmit or not, you are ready to tolerate some failure of the data, then efficiency or an efficiency comes into the picture. But if you are worried about the reliability, that means your data must be transferred, that definitely you are worried about the reliability. Even they consumes more energy, they takes more time, but you are worried. So it depends on your application, whether you are going in this direction or that direction, or use the fuzzy logic between lambda efficiency plus 1 minus lambda reliability and lambda varying from 0 to 1, like this one. So it depends on your application, what application you are using. But the routing refers to the process of forwarding the data from source to the sink node using intermediate node as a relay. Here we use not directly one hop, that means multi-hop communication is there. So some intermediate nodes are also there. So this is the responsibility of the routing. They also take care of the intermediate nodes. That means intermediate nodes have the both responsibility, collect the data and transmit the data. That means their framework, they support the routing protocol in the both aspect. And application or the advantage of the routing is helps to improve the accuracy, because you transmit the more data to the sink, then definitely you find out a more accuracy, and timely you can find out efficiency of the sensor node collect and processing of the data. So these are some advantages that they help to the wireless sensor network when we use the routing. So select the routing which is suitable in that categories. Now, objectives of the routing in the wireless sensor network. When you do the routing, what objectives keep you in mind? Every time the energy comes into the picture in wireless sensor network. So whenever you select the routing protocols, whenever you select the routing technique, you must be worried about the energy consumption. Select the routing protocol which consumes the less energy, so that your network can survive more and more. So routing protocols should minimize the energy consumption by reducing the number of transmission and receiver as well as the distance between the nodes. So they can select the shortest path like this one, so that the energy consumption goes down. There are two paths are there. One is the A to B, B to C. Other one is the A to D, D to E, E to C. So there are the 3 hub count. Here we have the only 2 hub count. So 2 hub count is better than 3 in terms of the energy consumption. So definitely this is the responsibility of the routing. They find out the shortest path so that we can reduce the energy and the time. Another energy efficient routing protocol, they also worried about the packet format or the header size and other things. So if you use some heavy header size or use some bulk information as a control information, definitely that is not suitable in terms of the energy consumption. Now reliability is also the another part of the routing protocol. That means usually wireless sensor network we deploy in the forest fire monitoring, some sort of thing that or disaster monitoring. So these are the hazards environment and may have the limited connectivity. That means if your routing is not working perfectly, you are not able to do anything. So routing protocols should ensure the reliable delivery of data even in the presence of the network failure. So if one network goes down, then routing protocol is much more capable. They can find out the second best path. Of course, the first best path is already there, they tear down because of some failure is there. Then they can go in the second best path. So most of the case, these routing protocols or the relay node, intermediate node, they can save the 2 or 3 path. One is the best path, second best, third best. If one node goes down in the first best path, they can go in the second one and they call the second one. Scalability is the another important point, because wireless sensor network is a large number of wireless sensor network in the network. So definitely scalability comes into the picture. You deployed a large, so your routing protocol supports the thousands or even millions of the nodes simultaneously. that means the header size is increased whenever you transmit the data from A to B, B to C. They can every time they can add the values like this one, or whatever you use the some constraint is there, that is every time they increase +1 in the hop count. So whatever the size of the +1 integer, that is so long, so that you can support up to the thousands of the node. And low overhead, that means whatever your additional overhead in the network, that is the low. Control packets information. So if you use huge control information, then definitely that is not suitable for wireless sensor network node because of the processing and memory resource constraint. Of course, the load balancing is also an important part. So every time, don't assume that you select a one path and transmit all the data in a given path. If the load is high, routing protocol responsibility is to diverse the load from one part to the another part to avoid the congestion and the distribution traffic. Otherwise, congestion comes into the picture and bottleneck comes into the picture, and this is not working perfectly. Now, based on the algorithm, based on the technique, routing protocols can be classified into various classes. So, one is the flat routing protocol, which is the simplest routing protocol. That means distributed routing protocol, where all nodes have the same responsibility and communicate directly with the same node. Whatever data is there, I can take the data, I can directly communicate the sync. This is a flat routing protocol, but practically that is not much useful. Why? Because of the direct communication and other things. Hierarchical routing protocols, they support some tree structure sort of thing, that or the levels, divide the network into the multiple levels. This is the level 1 devices connected to the level 2, level 2 only devices can connected to the level 3. All level 1, but that means level 1 devices cannot directly connected with the level 3. So in this case, the level 2 devices are always the high energy nodes, such as the cluster head sort of thing. So cluster head can communicate to the sync node, and other nodes can communicate or connected with the cluster head nodes like this. So here we can call it the hierarchical routing protocol because they have some hierarchy, that low energy node, high energy node like this one. Third one is the location based routing protocol. So they have the location information, and they use this location information for selection of the path. Here they are not worried about the location, they worried about the node type, that whether this is the suitable for the cluster head or not. Here we are worried about the location, that when you find the routing path, when you run your algorithm, you are worried about the location. This that means this node is so far, so why I am forwarding my data to that one, I can go in that way. So this is the location based information. And the another class is the data-centric routing path. That means whatever the data, who else is responsible, who is the take care of the data, where the data is collected like this one. If you worried about that, if your algorithm is take care of these things, then you can need to go to the data-centric routing path. Another is the power. That means if you want to reduce the energy consumption, that means you need to focus only on power aware routing algorithms. That means you select the path, they have the sufficient energy, they consume less energy like this one. In that case, we are not worried about hierarchy, whether the hierarchy is maintained or not, location is there or not. We worried only about the energy consumption. Sometimes the energy consumption is not only the quality of service, your quality of services such as the delay, throughput, and your packet loss and all other things. So if you are worried about that type of the quality of services, you need to consider the QoS-based routing protocols. So here we are not worried only about the power consumption, we also worried about the other type of the quality of services. Now these are the classification of the routing protocol, how we can classify the routing protocols. Another classification of the routing protocol is based on the storage based on the demand sort of thing. So say for there are two classes, one is the on-demand routing protocol, other one is the table-driven routing protocol. This is another class of classification. And on-demand routing protocol establish routing path only when they are needed. Okay, there is no routing path initially, you are completely free of mind, node has no information about the route. But when the node need to transmit the data, they create a path. They create a route sort of thing from source to the destination. So in that category, we can say when the demand comes into the picture. So when a node need to send the data to the destination, it initialize a route discovery process to find a path to the destination. And of course, they make a path and transmit their data. AODV is the well-known routing protocol in that case, in wireless sensor network and a rope network. And of course, the another is the DSR, dynamic source routing protocol. So these two routing protocols, they are the on-demand routing protocol, and when you require to transmit the data, you can transmit the data. Another is the table-driven routing protocol. That means in that case, routing protocols maintain the routing tables in all the nodes in the network. That means each node they have the information about the other nodes. You have the routing information. Whenever you have the data, you can start transmission of the data. You are not worried about to collect the information of the network, make the routing path, and then you can transmit. So delay is very less. You already have the information in table driven. So table is already there. Table has the information about the node, about the maintain the routes and how we can make the routes and all other things. DSDV is the well-known routing protocol, is the table-driven routing protocol. So these two routing protocols, they have their own advantage, disadvantages, such as the on-demand routing protocol. In the memory point of view, that is good because you are not required to save any information. If the network is so dynamic, that means nodes comes into the picture very frequently, they can change their location, then AODV is the good one option. Why? Because otherwise every time you need to update the tables. Here there is no table, why we are required to update. Whenever we need to transmit the information, we can collect the network information, make the routing path and transmit it. So in that case, we can say we are not worried about making the path, already save the information and do all these things. So on-demand routing protocol is suitable in terms of the space complexity for saving every time the information, and in terms of the dynamicness. If network is so dynamic, nodes are have some mobility, then this is good. But if you want to transmit the information as soon as possible, whenever the information generated, even you have not able to wait the time till the routing path discovery and other things, then table-driven routing protocol is good. You have always the updated information. Whenever you have the data, you can take the routing protocol to transmit the data, and you can successfully transmit the data in that categories. We can see some little bit information about the AODV, DSDV and DSR routing protocol. So AODV routing protocol, as we already seen that this is the on-demand routing protocol, meaning that routes are only established when need, rather than maintain the constant routing tables. That means you can make the routing path. Earlier there is no information for that one. Another feature of this is their name suggests the distance vector routing protocol. That means they work with respect to the distance. So if I have the two paths, I can select a path which has the least distance and less distance as compared to the other one path. So this is the distance vector based, and in terms of the communication, we can say hop count. So node A transmit to node B transmit to node C. That means in that case we can say this is the two hop count. So AODV routing protocol select a path which has the less hop count. So this is the distance vector. And how they can make the path? They use these type of packets and the messages. So here very first route discovery comes into the picture. When a node need to send the data to another node for which it does not have a route, it initializes a route discovery process which flood the network with the route request packets or route request messages. So whenever you have the information, you flood the route request message. Whatever the neighbors are there, they receive your route request message. Okay, and whenever a node receives the route request message for a destination for which it knows a route, it sends the route reply message back to the source node, if they have the destination information. Otherwise, what they will do, they forward this route request message to the another node. If I have the destination information, I have the sync information, what I will do, I will reply back as a route reply back message to the source node. So with the help of these route request message and route reply message, AODV can make the routing path. And this is the hop by hop routing protocol. As we already see that this is the distance vector based. That means each node forward a packet to the next node along with the path to the destination. So if I have the information, the path A to B, B to C, C to D with the help of these two messages, and when we transmit this data, I have the that means the path information, hop by hop information, that how we can transmit this data from this one to the next location. AODV routing protocol use the sequence number which prevent the routing loop. So what is the looping problem? That means, say for example, A send to B, B send to C, C also again send to the B, B to D, like this one. That means the packet is moving inside the loop, not source to the destination like this one. So how we can prevent this one? We use the sequence number. If the sequence number is same as the early one, that means the sender understand that okay, this is my own packet that I forwarded to the neighbors, neighbor forward to the neighbor, and once again this packet comes that neighbors to me. So with the help of sequence number, I can avoid that one packets or the information so that we can break the loop sort of things. Route maintenance is also there. They have the messages for route maintenance, and they periodically they broadcast such type of the route maintenance packet so that they can understand that whether the path is still exists, whether the route is still there or not. And AODV routing protocol not only have the one option, they have the multiple supporting options. So for example, if they find out the three path, one path is the shortest, second one has the not as good as one, but that is also a good one, and third one is the only the path that is there. So we have the three paths in that case. So AODV routing protocol calls the first one path, which is the shortest path in the network in terms of the distance. If the path has some problem, then AODV routing protocol calls the second path. That means multiple route support is there. So that you are not required to every time you can go and select the second path, make the path and other things. You have the option to transmit this one. And this routing protocol is suitable for the small to the medium size. That means this is suitable for the medium size, not only for the smaller, because you are not worried about to update the information. Whenever you want to send the information, you can create a path. That means you can maintain a big size topology networks in that case. And because of this beauty, and this is a very well-known protocol, they have the standardized, that means IETF, they give the standardized of this AODV routing protocol. And right now, various devices and simulation, they have the AODV routing protocol. Now we go to the another on-demand routing protocol. This is also a reactive routing protocol, which is the DSR routing protocol. So dynamic source routing protocol, this is also same as the previous one, on-demand routing protocol. That means whenever you require, you can make the path. And this is the source routing protocol where entire route is including in the packet header by the sender. So whatever the route you have traced, you need to make the entire route information inside the packet header. You are not able to select, that means, okay, I can put the information only last two hops. You need to make the entire route information, because this is the source routing information. When a node wants to send a packet, it broadcasts the route request, similar as previous one, to their neighbors, which forward by the other nodes until they reach to the destination. And if that's the fresh route destination, then they put in the cache memory and reverse back to inform to that, yes, there is a one path is there. So everything is same as the previous one, only that is they have the entire route information starting from the source. Similar as the AODV, they also support the multi-path routing protocol. That means they have multiple options are there so that they can save their routing information. And yes, there are some challenges in that in the DS routing protocol is the flooding attack. That means when you find out the path, you broadcast this information or flood this information to the entire network or entire nodes like this one. So that means maybe possible you are a correct node, but maybe possible some are the malicious node, they also do the same thing. So unnecessary route request messages comes into the picture and they disturb or interrupt to the communication protocol in this. And similarly, this is also good for the small and medium size, because you are not required to save the entire information. And whenever you require the information, you can create the path. So good for the military communication, disaster and environmental cases. Third one is the DSDV routing protocol, and this is the first one is the preemptive routing protocol. That means in that case, you have the table information, entire information saved inside the table, entire network topology information saved inside the table. And this is based on all pair shortest path Bellman-Ford algorithm in data structure, if you go through. So make the matrix, find out the shortest path working accordingly. Okay. So each node maintains a routing table that contains the information about the next hop to reach a particular destination. And of course, they need to periodically update this information so that every time they have the updated routing table. And they also use the sequencer number of each route. So differentiate between the old and new route request. So maybe possible this route request is the older one that is inside the loop. You receive once again the same information. So to avoid such type of constraint, that they use the sequence number to avoid the routing protocol. And this is the distance vector, similar as previous one, to calculate the distance and direction to the destination. So that is also similar as the hop count. That means 2 hop count, 4 hop count. Which one path is better? 2 is the better as compared to 4 hop count. Take this one. But they support the small network, not the large network or the medium network. Previous one, they both support the medium network and the small, of course. Here they support only the small network. Why? Because of the table required. So if your network is so large, your table size is very big. Whenever a node changes their position or whenever a node goes outside, because of the low mobility, you need to update your routing path like this one. And another is the count to infinite problem is there. So that means that advertise a new route within the known matrix to the destination node. Always use the longer route like this one. So they always rotating in the loop and loop and advertising. So count to infinite problem comes into the picture. And this definitely they need to take care of all these things. So these are the three protocols they use for the data transmission. And we can easily classify into two categories. One is the on-demand, other one is the travel demand.